Good day, dear followers of geometric tutorial programs. You are welcome to this Artlantis animation tutorial class. The aim and objective of this class is to equip you with the knowledge of creating motion renderings, otherwise known as animation, with Artlantis Studio. Now, there are factors to consider. Factors to consider for successful achievement of motion renderings with Artlantis Studio are: number one is your PC capacity. It is very important to note that a PC of lower capacity will consume much time in rendering an image, and a PC of higher capacity takes shorter time to do the same process of work because the processor is faster. Number two factor to consider is the radiosity counts and polygon counts of objects. If you put heavy objects in your renderings, it will take longer time for the machine to calculate the polygon counts before the image is ready. So when doing your motion renderings, you should try to avoid the use of heavy objects or objects that have high polygon counts. Then the third factor to consider there is the presence of light and neon shaders. Now, when you have so much light in your model, if you put too much light in your model, remember, when the rendering machine starts rendering the image, it takes longer time for it to calculate the radiosity count of the light. Likewise, the neon shaders. Neon shaders makes the calculation time of the machine to prolong. You try and avoid that neon shaders and also avoid the use of neon lights. That is for those that are making use of lower capacity of a PC. Those that have high capacity of PC can go ahead and introduce few of these materials where necessary, but not much, so as to avoid weighing down your PC. Now, when you open your Artlantis Studio and you have your model present like this and you want to do motion rendering, first, there is this thing that you need to know about motion rendering in Artlantis, the importance of motion rendering. You see, most of the times when you have a client you are working for and you just finish modeling your building and you bring it into Artlantis Studio for rendering, you just render the images, like you render the front view, side view, back view, and you send it to your client as a means of communicating with your client what the building will look like in real life. Now, that might be it might give your client realistic knowledge of what his project looks like. But when you create a motion rendering of that image, motion rendering gives broader knowledge, because in motion rendering, your camera will navigate around the building or to some extent of the building. It helps the client to understand completely how the building looks like while moving from one side of the building to the other side of the building. Now let's go into animation with Artlantis 5. I've had people saying that Artlantis doesn't do animation, or if it does animation, it takes much time, but I want you to see it now as we engage in it. Now, once you open your Artlantis model like this, you move from this spot, change it to animation. Click on this, select the animation. If you select the animation, probably you will have this encounter that I have on the screen now. You can see the encounter I have here. Everything looks blank, like my object is missing. Look at where you can get your object. You can see it is selected now here. So you click on it and check this off. Once you check this off, the whole of this materials here will come up. Let's check it off. You can see your object, your model has just appeared. Now you click on your ground. You on your ground. That's that. Now we are in the animation mode. There are few informations that I want to explain in this animation mode. Now we have this ribbon here. It is called the name is timeline window. This is your timeline window. This is where your window records the time interval for a particular motion. Then the next one is this time scale. This is time scale. Now, what is the use of this time scale? If you move it up like this, you see as it lengthens this timeline window. If you bring it downward, you move it towards the left, you can see what it looks like now. It reduces the timeline window, and you can now count from this spot to this spot is 5 seconds, from here to here is 10 seconds, 15 seconds, 20 seconds, 25 seconds. Now, if you want to obtain fractions of seconds, you increase this timeline. Now, as you increase this timeline, fractions of seconds will appear. You can see from this spot to this spot is 1 second, but we now have microseconds that can be seen now. Why? Because you moved towards the positive position. So let's move it down here so that we can now have only the seconds. Now, when it appears like this, you move this. You press down your cursor on this, and move it to 0 limit and stop there. Then take a look at what you have here. What you have here is picture frame. Now, the number of picture frame your image is going to render before converting them into a video clip is what is here. Now, each number of picture frame is directly proportional to the time allotted to such a rendering. Like here, the time here is 10 seconds. Now, once it's 10 seconds, it will count 251 picture frames. So if this image is going to render now in animation, it is going to render 251 picture frames before it now becomes a video. Now, if I increase this time frame, watch what is happening. As I'm increasing this time frame, the figure there keeps increasing. This figure here keeps increasing. Now it is 378. That is if the time interval of the rendering is about 15 seconds. If I move it to 20 seconds, the picture frames that will be rendered will be 502. So the longer the time frame, the bigger the picture frame. I hope that is understood. The longer the time frame, the bigger the number of picture frame. So the smaller, as I move down, notice why I move this down. Notice the change in figures here. So as I move it down to 5 seconds here, we'll have 127 picture frames to be rendered. I hope that is understood. All right. Now, one other thing that is important before embarking on Artlantis animation is the use of your 2D view. Look at it here. This is your 2D view. Now, with this 2D view, you position your camera and position the focus. Now, in this 2D view, this blue dot stands for your focus, the focus of the camera, while this red dot stands for the camera itself. Now, there are two arrangements for this camera. At this spot, you will see there are two arrangements you see there. One is target on fixed vertex, while the second one is target on path. Now, this target on fixed vertex is the setting we have here. Like when you have this, your blue dot at this spot, and you have your camera here. Now, watch something. Whichever way you move this camera, the focus remains where it is. And once the focus remains where it is, it means that any movement you make will always give you a view of the side of your building or your model. Like as you can see, as I'm moving right around the building. Let me drag this by one side, show you something. All right, you see, as I'm moving this camera right around, with the focus centered on the building, I am seeing different parts of the building. You can see it. With the focus centered on the building and the camera movable. In this case, camera is movable, but the focus is not movable. That is number one setting. The second setting is if I change it to target on path. You see where it turns to? Target on path. Now I want you to observe the difference between the two motion. Now, whenever you move this, you see once you move the camera, the focus moves with it. So we make use of this setting when you want to move in a linear direction. For instance, you are traveling along a road. Now you grip by the side of this place and move it towards the road. Beautiful. Now let's move. If I move this camera, you observe something. We are moving only in linear direction. You see? So this is used when you want to move in a linear direction. And when you are moving in a linear direction, all you'll be seeing is all that are in front of you and not by the side you, except anyone that appears within the cone of vision of this motion. For instance, if you get to if it is a moving vehicle that is traveling along this road, you get to this point and wants to turn, maybe we grip it at this place and rotate it again towards this road, and it turns towards this road, then it moves. So it's for linear direction movement. But in this motion rendering that we want to do this moment, we'll be making use of these setting. Fix on target. We'll be making use of it so as we can be capturing our building while we move. So move the focus of the camera to the building. That is number one. Then the next thing we do is we increase the cone of vision. Let's say 75. Beautiful, so that it can spread and capture wider area of the building. That done. Then the next thing we do is you click on this the architect's camera. You click on it, on, and that's for that. We have done these simple basic settings. So what we'll do now is we'll have to bring in either objects and do object animation or do camera animation. Now I want to bring in object first. I want to bring in an object first so that you see how object is animated. Now click on object here. Object will not show on this time scale. What you do is you click at this spot so that you can have your media and pick an object. Let me pick human being. You select this human being, drag the human being, drop the human being here. The human being has just appeared. Now use this 2D view and set the human being. Rotate the human being. Now, we are going to move this human being from this spot into the building. So, we are going to animate him to walk into this building. I want you to see how that is done. Now, having put your human being here, you click at this spot. See this spot here? Click on it. The moment you click it on, then drag this human being. You will see a line just appeared. Drop him on the top of this place. So it means that the human being will move from this spot to this spot, but not on this straight line. He will have to move in a L path, in an L path. So to add, you have to add a control point by right clicking. You right click on this green line, and this information comes out. You now add a control point. You see a control point has appeared. Then drag the control point, bring it out here. Bring it out here. Then straighten this. Straighten this to be along the green line. Beautiful. Then this one also, straighten it to be along the path of the green line. I hope that's understood. Now, there is one more thing I would want you to understand about this motion. You have to check your the side view to see if there is an upslope movement there. Click on this. Let's observe. You observe the land at this spot slopes upward. There is a ramp here, meaning that the movement of this man, once he gets to this place, he has to climb up ramp. So we are going to arrange that motion as well so that it doesn't, the legs doesn't seem like it's submerged. Because if you leave it like this, you see the path, you see this green line, that's where the level of the leg will be. And once the human being walks up to this level, the leg will be hidden. It will be like the leg is sinking into the ground. So we are going to move this part up, drag this one up to this level. This is the ground level of our site. Take it up that level. Then add another control point by right clicking. Add a control point. Our ramp started from this place. See at this spot. You drop the control point there. Then unlock the tangent. What do I mean by unlocking the tangent? Unlocking the tangent makes the two ends of these lines to be to be independent of each other. Like this one now can lie flat, while this other one will lie in a sloping direction. You can see it can lie in a sloping direction. You see it lies in a sloping direction while this one moves this way. Then we'll have to add another control point at this spot. The takeoff of the ramp from here gets to this top level. So we'll create another control point here by right clicking and add a control point. Then drag it and drop it at the takeoff point of this of the ramp. Stop here, right click on it and unlock the tangent so that this arm can be free. It will now go up this level. Beautiful. While this other arm can now lie on the horizontal level of the road. By this way, the human being who takes off from this level will get to this place, climb up ramp. As you can see the position, it's like he's climbing up the ramp. Once he gets to this level, he moves in a horizontal direction and gets to this place. That is the settings you give to it. So let's go back to our top view level. So you can see what the motion looks like. Now we have arranged the human being as the human being will be. So let's on our timeline again so that our timeline will appear. You can see our timeline. Our timeline looks disheveled. Now this movement that the object moved from here to this place has a time frame that is allocated to it. You can see the time frame. The time frame allocated to it here is about 13 seconds and a fraction of 17. 13 seconds and a fraction and microseconds of 17. So you can see the position of the human being here. If we want to return the human being back to the origin, to his starting point, we click at this place. You see the bar goes back to his starting point. Now, once this is the human being's position, there are things that you should understand about the position of the human being and the time frame. Here we have 13 seconds. You can minimize this time frame because you can minimize this time frame or increase the time frame depending on the nature of the motion you want to achieve. For instance, if I move this time frame to 3 seconds, move this back, move it back. This is my 1 second, 2 seconds, 3 seconds. Let me move it to 3 seconds and show you something. Let me increase the micro so that we can see it properly. Move it to this spot. 3 seconds exactly. Once you move it to that point, you also move this to that spot. Beautiful. Now, I want to show you something. You click on this. Once you click on this, the entire line turns into white. Let me click on it so that you see something there. The line has turned into white. Now, let's play it. Now, these 3 seconds, you can see it is just 76 picture frames that the machine is going to render. It just has 76 picture frames. Now, let's see what motion it will look like. Let's play it here. You click at this spot and play it. Watch. It seems like the human being is jumping. Seems like he is jumping. You see? Seems like he's jumping. But watching the movement of the motion of this human being up to that point doesn't give us an appreciable look. So what you do is you click on your OpenGL. This OpenGL, click on it. The whole of this place turns white. You see, it has just turned white. Then move the human being back to his origin by clicking at this spot. Goes back to his origin. Okay, let's replay it again. Let's see his motion. You see, it's moving very fast. Moving very fast. Does human being move like that? No. Human being does not move like that unless that person is running. Okay, the human being will put, you can see the behavior of the human being, walk loop. So let's change the behavior of human being to be slow running. But to do that first, let's move the human being back to his former position. Then let's change his walk behavior to slow running. I think this slow running agrees with this time frame of 3 seconds. Let's see. Let's replay it again. You see? He stopped halfway. The human being stopped halfway. So, let's go back again. Something happened here. As we change it to slow running, the time frame changes again. But we want to move the time frame. Everything must be within 3 seconds. Let me move it back to 3 seconds. Let it be 3 seconds. Beautiful. Okay, let's replay it so that you see. Do you see? Beautiful. So, it's a slow running. I think this slow running agrees with the time of 3 seconds. So, the behavior of the human being must also agree with the time that you are allocating to it. So, these 3 seconds will be good for behavior of walk loop. Walk loop does not agree with 3 seconds of motion. So, nobody moves a distance of from here to this place in 3 seconds. It's almost impossible. You can count 3 seconds with your heartbeat. With your heartbeat, you can count 3 seconds. And you know very well, one cannot walk from this place to this spot in 3 seconds. It doesn't add up. Except you talk about slow running, it's possible. Because one can run at a fast speed to get to this spot. So let's move it back again and replay it again so that you see what it looks like. Let's play it again. You see, the slow running. He was able to accomplish that task in 3 seconds. Let's move back. Let's move him to his former position and change his walk behavior to walk loop. So we have changed the behavior to walk loop. But because it is the behavior of the man is walking, so we are going to increase the time to 10 seconds. Let's see what it looks like. Increasing. Stopping at 10 seconds here. Then move this to 10 seconds as well. Let's use this to get the microseconds that is added there. Beautiful. Then also move this one back a bit. So it is 10 seconds of motion. Now let's see the movement of this man to this place in 10 seconds. Let's play it and see. Now he's walking fast. Yes, he's walking fast. He's walking fast. Beautiful. I think this 10 seconds agree with the motion of the man. So let's move him back. Now with this, we have set the motion of the human being. Let's move the human being back to his former position, and let's make a little movement here. All right, let's replay it again and see the movement of the young man. Can you see the movement of the young man? Beautiful. Let's return him back to his original position. Now we have achieved the motion of the human being properly set. Then we'll exit this OpenGL so that our preview will remain as normal as it is. Just check it off. Then the next thing we do now is camera animation. Camera animation, the motion of this camera. That is what we are going to set this moment. We'll set the motion of this camera. Now I want you to see how we set the motion of the camera. The essence of doing that is we want the camera to be moving alongside with the human being as he moves into this place, so that we see the beautiful scenario that we are going to obtain there. So let's position our camera, making sure it is focused on the building. Making sure our camera is focused on the building and the man. Okay, beautiful. Our camera, if you look at it, you see the camera captured the building and also captured the man. Now, I want you to observe something. Once we move our camera this way, you see, we are able to see our building from one side to another side. You see that? We are able to see the building from one side to another side. So let's return it back to its former position. Now, we are going into animation of the camera. Once you go into animation of camera, you go out of object and click on this animation. You click on animation. Beautiful. Now, to animate your camera, because we are in the camera mode now, you click at this spot again. As soon as that spot appears, you move your camera from here. You pin your mouse here and drag your camera. Notice a line will just appear. A line will just appear. Beautiful. Now the line has just appeared. So it means while the human being moved from this spot to this spot, our camera also moved from this spot to this spot to capture the motion of the moving human being and as well as the building. So, having done this, we'll click at our return. We click on this so that the camera will go back to its original position. Once the camera goes back to its original position, even this human being will also return back to its original position. So let's click on return. You see, both human being and camera have returned back to their former position. Then, if you click on this spot, this turns green. This turns, it turns red. It turns red, showing you that it's ready to go. So let's open our OpenGL again. We click on it, and then let's play the whole setup so that we see how the camera moves and how the human being moves as well. Let's see how the whole setup looks like. Let's play it. You see, this time around, our camera is moving while the human being also is moving. You see, that's beautiful. That's beautiful. Let's return it again and replay it. The whole setup must look beautiful in your eyes before you move into rendering. So let's play it again. Now, how do you see this motion? The motion looks cool. The movement of the human being looks cool. It means that this is good to go. Beautiful. So let's return the whole setup back and then close this OpenGL so that our rendering will now render this image completely. Now, the time it will take for the whole of this picture to be rendered is what? 10 seconds. You can see the setting is on 10 seconds. And the number of picture frame that we rendered here is 251 picture frame. 251 picture frame. So we'll go into setting of the picture frame. go into the settings, the rendering settings. So you exit this, then go to this spot. You want to commence the rendering. You have rendering size, the custom rendering, and the normal rendering size that is here. So let me choose my rendering size. I have this, I have slightly bigger, and I have the biggest. I like making use of this. But if you make use of this resolution, size of picture, it's going to take you longer time to render, depending on the capacity of your PC. If you have a lower capacity of PC, make use of this. But if you have a big capacity, all these alien ways that have up to 12V dedicated graphics, you can make use of this, and it will render it in with speed. So to do that, I'm going to take this. I'm going to divide the half of this value and write it here, half of this value and write it here. So the half of this one will give me, the half of it will give me 960. 960. While the half of this will be 540. 540. That done. Then I will change my lighting setting to exterior, because this is exterior rendering. And then make sure that this place is green before you now click to render. Then you choose, if you are rendering the entire 251 pictures, if you are rendering the entire 251 pictures, that means you're going to leave it at all. But if you want to render from a particular picture frame to another picture frame, you click at this spot and know if you are selecting from 1 to 76 or from 1 to the entire. But I want to render the entire picture frame, so I'll click on this. The 251 picture frames will be rendered, and then get a name for the video that will be recorded later. So let me call it a scene 2. Scene 2, and then click on save. Having clicked on save, I'll now click on OK for it to start rendering. It has started rendering. The whole of these 251 picture frames will be rendered. I just rendered the first picture frame and it's rendering the second picture frame. You can see it here. It will continue until it renders the entire 251 picture frames before it becomes a complete video clips. You see, the picture frame count now is 200. Within a short time now, we'll get to 251 picture frame. So it is rendering the 200 picture frame. It's rendering the 200 picture frame. Let's exercise patience as it completes its work. Now you can see it is now rendering the 231st picture frame. You can see it there, 231. Let's exercise patience. Let's exercise patience. This is now 232 picture frame that is rendering now. Exercise patience, soon it will be done with it. Now this is the 250th picture frame. Now it's 251 picture frame. So I think this is the final picture frame. Once it's done with it now, it will show us the position to close the rendering. Exercise patience as it clears the screen. Beautiful. You can see now at this stage, click on close. Then minimize the drawing board screen so that we can see, so that we can search our desktop for the video we just created. So we minimize. Go to the folder here and search for it. You can see, where is it? Scene 2. You can see the video animation here. Let's open it and see. Let's open it and see what it looks like. You see the motion of the human being as he's moving down with our camera moving as well. This is beautiful. This is beautiful. Now with this, I hope you have learned one or two things on how to do simple motion rendering, otherwise known as animation with Artlantis. I hope you enjoyed this tutorial. Please don't forget to like our videos and share it, and as well as subscribe after watching it for every update that we have. Thanks for watching.